In the previous video, we discussed the sampling distribution with non-standard deviation. In most sampling situations, the population standard deviation is not known. In this video, we discuss how to estimate the population parameters with estimators from sampling distribution with unknown standard deviation. In this example, if we do not know the standard deviation either, we can use the sample standard deviation to estimate the standard deviation for the population. That is, S equal to square root of summation from I equal to 1 to n of x sub I minus x bar squared over n minus 1, where n is the sample size. Given that the standard deviation of the population is not known, the standard deviation of the sample S is used as an estimate for the standard error, which is given by SE approximately equal S over square root of n. Because we do not know the population standard deviation, we do not use the z value anymore, but instead we use the t value associated with a sample size of n, which is given by x bar minus mu over s divided by square root of n follows a t distribution with n minus 1 degrees of freedom. T distribution, also called student's t distribution, is an adjustment to the normal distribution because we do not know standard deviation of the distribution. The t distribution is symmetric and bear-shaped, like the normal distribution. The characteristics of the t distribution are based on the assumption that the population of interest is normal or nearly normal. As sample size increase, however, the t distribution approaches the standard normal distribution. The shape of the t distribution depends on the degrees of freedom, df, which is given by n minus 1. In practice, for samples of size n larger than or equal to 30, the t distribution is approximately the same as the normal distribution. So the estimates that we will obtain from the t distribution will be similar to those using the normal distribution. In this situation, we may use the z value instead, although we may use the sample standard deviation S to estimate the population standard deviation, sigma. However, if the sample size is less than 30, we must use t distribution rather than normal for confidence intervals and hypothesis test, as we will discuss further later. Recall the confidence interval defined in the normal distribution. We can also obtain the confidence intervals for the sampling distribution with known and unknown standard deviation. More specifically, for those with large sample size, if we know the standard deviation of the population, then we have the confidence intervals defined by x bar plus minus z times sigma divided by square root of n. If the sample size is large and the standard deviation is unknown, then the confidence interval is given by x bar plus minus z value times s divided by square root of n. If the sample size is small, but if we know that the population distribution is normal distributed with non-standard deviation, then the confidence interval is given by x bar plus minus z times sigma over square root of n, which is the same as that with large sample and non-standard deviation. If the sample size is small, but if we know that the population distribution is normal distributed with unknown standard deviation, then the confidence interval is given by x bar plus minus t value times s divided by square root of n. Of course, if the sample size is small and the distribution is non-normal, then we do not have a good estimate for the confidence intervals now. Similar to the Z table, we have a T table as shown here. Suppose we know the probability of the right tail, say 0.025 or 2.5%, then the T value for a sample size of 12 is given by the column of T sub 0.025 with a degrees of freedom of 12 minus 1 equal 11 is 2.201. Reversely, if we know the T value and the degrees of freedom, we can then find the probability. In this example, a tire manufacturer wishes to investigate the tread life of its tires. A sample of 10 tires driven 50,000 miles revealed a sample mean of 0.32 inch of tread remaining with a standard deviation of 0.09 inch. Our first task is to construct a 95% confidence interval for the population mean. The second task is to answer the following question. Will it be reasonable for the manufacturer to conclude that after 50,000 miles, the population means amount of the tread remaining is 0.30 inch? To solve the problem, we first obtain the T value. Given that the confidence level is 95% and we have a sample size of 10, and because the confidence interval has two sides across the mean, we check T value at the alpha level of 1 minus 0.95 divided by 2 equal to 0.025 and the degrees of freedom of 9. Find the interception point of T sub 0.025 and degrees of freedom of 9. We have 2.262 as the T value. Because we do not know the population standard deviation, we use the sample standard deviation to estimate for it. Then the confidence interval is given by x bar plus minus t times s over square root of n equal to 0.32 plus minus 2.262 times 0.09 over square root of 10, which is equal to 0.32 plus minus 0.064. In other words, the 95% confidence interval is given by the range of from 0.0256 to 0.384. That is, the manufacturer can be reasonably sure 95% confidence that the mean remaining tread depth is between 0.256 and 0.384 inch. A further interpretation of this example is that if we repeated this study 100 times, calculating the 95% confidence interval with each sample's mean and standard deviation, we expect 95 of the intervals will include the population mean. 5 of the intervals will not include the population mean. Because the value 0.30 is in this interval, it is possible that the mean of the population is 0.30. In this second example, we are examining the salary level of female employee of a company. Some board members of Artsy Corporation, a large multinational company, are concerned with the issue that women are being discriminated in the company, in the sense that the salaries are not the same for male and female executives. Based on a sample size of 26, we can obtain that the average female salary is equal to 62,577 pounds. The standard deviation is given by 7,337 pounds. And the standard error is given by 7,337 divided by square root of 26 equal to 1,439. The t-value of 95 confidence level with 25 degrees of freedom is 2.06. So we are 95% confidence that the true value is in the range of mean plus minus 2.06 times SE equal to 62,577 minus 2.06 times 1,439, comma, 62,577 plus 2.06 times 1,439, which is equal to 59,613, 65,541. We can also use Excel to compute the confidence interval. Before doing so, please install the data analysis add-in from Excel. If you have not done so, you may go to Excel, File, Options, Add-ins, and Data Analysis. Then you can run the procedure by going to Data, Data Analysis, and Descriptive Statistics. In this Excel example, we are going to demonstrate how to get the descriptive statistics again, and based on the information to compute for the confidence interval. Okay, so I already plug in the data of the female salaries here. So I also give you the demo of the descriptive statistics step by step here, and that's the way to get confidence interval. But today we are going to repeat the whole process over here, and we can demonstrate how to get the confidence interval. So let me try to get the full tab. So we can go to the data and data analysis. And we have a pop-out of different kinds of choices we have done before. And here is descriptive statistics, and we click OK. So in the pop-out, we are going to select the data, entire data set. We can just going down to, okay, a little bit too much. So anyway, we can use the to select from B2 to B28, and we return here. Given that this is the column and I include the label female salary in my data, so you need to click labels in first row. Here I prefer to show the data on the same sheet as well. So I set output range here. So I need to specify the location of the data output. So I'm going to put over here. And you need to specify what kinds of information you need. First, you need to have summary statistics so that I can have the mean. And you are going to specify the confidence interval level as well. Here we have the 95% the confidence level, but if you like to have 99 or for example 99, and you can do that as well. Okay, so we can just try 99, and of course you can also try the largest, the smallest, like I have done over here. But in this demo, we don't need to have that information, so I'm going to stop here, and I'm going to say okay. Okay, so I have the descriptive data about the mean. This is the mean information we need, and this is the confidence interval. Here, actually, Excel already put these two t-value and standard error together. So the confidence level information about this actually is the t-value times the standard error. So the way we are going to get confidence interval is going to be, let me show you over here again, but we can simply delete these values, and we are going to have equal the mean plus, we are going to start with the minus at first. That's the lower bound. So we are going to have minus the confidence level, and we say, okay, that's the lower bound of the confidence interval, and we are going to have equal to the mean again, and this time we are going to use plus the confidence level, so we get the upper bound of the confidence interval. So this is the 99 confidence interval values. As I said, you can change the value of the confidence level so that you can obtain different kinds of confidence level confidence intervals. Okay, so hopefully you have practiced this together with me step by step. You can temporarily pause here to make sure you fully understand and get the values you want. Again, this is the lower bound. You use the mean minus the confidence interval level, and this is the upper bound will be equal to mean plus the confidence level value. So you get lower bound, upper bound for the confidence interval. And that is 99% confidence intervals. And the second value I show here actually is 95% confidence intervals, as I show on the PPT slides. So let me go back to PPT slides. Let me summarize this video. In this video, we introduce the concepts of standard error in sampling distribution with unknown standard deviation. We also discuss t-distribution, t-table, confidence intervals with t-value.